Thank you for joining this lesson. We're going to discuss mathematics paper 1. Paper 1 is usually content from all the... So whether you are a Form 2 student, a Form 3 student, a candidate this year, just join us and feel safe in this program. We're going to give it our best. It will be a discussion on a few questions here because we'll be doing section 2. We can see the first question is on statistics. That is statistics 1. We are told that the frequency distribution table below shows the mass in kilograms of parcels delivered by a courier to their office in Lubao. So we can see masses there according to the table. The masses are in classes 50 to 99, 100 to 199, 200 to 49, 250 to 349. Something you can conclude from this kind of a data is that the classes are not uniform. They are not equal in sizes. Then we have number of parcels, which is, for this case, the frequency. Then we have a frequency density, which is now blank, and we're supposed to calculate. Frequency density, let me share something here. Yeah, you can also share the link to invite a friend. Frequency density is usually given by frequency out of class length. Frequency of a class length. So the first thing we are advised to do is to complete the table above to 1 decimal place. So we take each frequency and we divide it by the class length. So the first class is running from 50 all the way to 99, whereby you should know that for us to get class length, we need to get the interval. For us to get the interval, which is the length, we need the upper limit 99.5 minus the lower limit 49.5. You just subtract. This is going to be 50. So we will take now a frequency of 380 divided by 50. This is 7.6. Yeah, 7.6. We have been told to 1 decimal place, 7.6. The next one is going to be from 99.5, that is the lower boundary, all the way to 199.5, and that becomes 100. So the interval is 100. So we'll be taking 230 divided by 100, giving us 2.3. 2.3. We're also having from 200 to 249. So this means 199.5 all the way to 249.5. That is when I use the boundaries. So the limit is going to be 50. So when I divide 160 by 50, I'll be getting 3.2. And finally, I'll be having a 349.5 as the upper limit minus the lower boundary of 249.5. Yeah, and this will give us exactly 100. Yeah, exactly 100. So I will take 170 divided by 100. This will be 1.7. So now we are having the frequency densities of this particular data. As you continue joining our lesson tonight, let me remind you of our program here, whereby people can purchase airtime for any network, as long as the network is working in Kenya. Safaricom, Airtel, Telcom, just go to your M-Pesa, Lipa na M-Pesa. The pay bill number is 737356. Then the account number is the phone number. Then now you enter the amount, you proceed with the transaction, and the airtime is going to reflect instantly. Yeah, the airtime shall reflect instantly. So please use this facility and also involve your friends in the same. Now let's get to the second part. We are done with filling the table to 1 decimal place according to the instructions. And now in part B, we are told on the grid provided below, draw a histogram to represent the information shown in the table above. So for us to draw a histogram, when all the classes are having equal width, we use frequency against class boundaries. But now that the class intervals are not the same, we are going to use frequency density against the class boundaries. Frequency density against the class boundaries. So frequency densities, I can see they are running from 1.5, the least, all the way to 7.6. So I can use, okay, let me see, there is some good space. So if I draw the axis here, on the vertical axis, I'll be having, so I'll be having frequency density at this point. Frequency density, yeah, that is where it will be. Then on this other axis, I'll be having the class boundary, so simply the masses in kg. So we'll have the boundaries here, whereby it is both upper and lower boundary for each class to represent the data in that particular class. Remember to subscribe, remember to share, to invite friends. On the x-axis, look at, we will be having the masses, and it's all the way from 50 to 249. Therefore, I can use intervals of 50. So allow me break the axis so that I don't start with 0. So it will be 49.5. Then after that, I can talk about now 99.5. Then let me check. Yeah, 99.5. Then we talk about 149.5, 199.5, 249.5, 299.5. Then I talk of 349.5, 399.5, 449.5. We go to 499.5, 549.5, and such. So I'm using intervals of 50. So now we can come up with the bars which will represent the data. The first bar, which represent the first class, will be 49.5 all the way to 99.5 with a height of 7.6. Or let me first indicate the frequency densities, whereby I can use intervals of 1 now in this case. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So now in the first one, 49.5 to 99.5, the height will be 7.6. 7.6. So 7.6 will be at this point. 7.6, that will be the height. So this will be the bar. This is going to be the bar, like that. Now the next class, which begins from 99.5 all the way to 199.5, will have a height of 2. 199.5. So 2.3, a height of 2.3. Yeah, 2.3. That way, 2.3. After 2.3, we go all the way to 249.5, but the height is 3.2. A height of 3.2. So 3.2 is at this point. Then 249. You see now, these are the bars representing each class. We proceed to the last class, 1.7, but all the way to 349.5. 349.5. The height is 1.7. So 1.7 is at this point. I hope we are together in the interpretation of the scale used. So now you see, this one is now the histogram that we wanted. Yeah, that is the histogram. So I hope we are together in that. When the data is not uniform, when the classes are not uniform, that's how we come up with a histogram. Yeah, that's how the histogram is done. Then there is a part C. Draw a vertical line. Draw a vertical line in the histogram where the median lies. Where the median lies. So we are supposed to look at, first of all, the total number of parcels here. The total number of parcels. So the total number of parcels shall be, the total number of parcels is going to be, we start with 380, we add 230, and that will be 610. We add 160, that will be 770, and we add 170, that will be 940. So we have 940. So the median mass is going to be, when we take 940 and divide by 2, is it going to be 470? 940 over 2, yeah, 470. 470. So the 470th parcel will have the median mass. 470th. Now, something else that you're supposed to know about this histogram is that the area of the bar represents the frequency. For example, the people in the first bar, we need 7.6, which is the height, multiplied by 50 for us to get the number of people there, which is 380. So we have 380 people in the first class. Yeah, 380 people. So in the first class, we're having 380 people. Then in the next class, we have 230. But do we really need 230? No. We need the number that when added to 380, we get 470. So 470 minus 380, we are getting a 90. So we only need 90 parcels. 90 parcels in the second class. And remember, the second class is already, the second bar is already having a fixed height of 2.3. So with a fixed height of 2.3, and we need the number of people to be 90. You know, number of people is the area. We want 90, and we are having a height of 2.3, and we need a certain length. So that when multiplied by the fixed height, we will get 90. So how we get the length? We take 90 divided by 2.3. So we need 39.13. 39.13. So when we add 39.13 to 99.5, we will get the median value, and we will be able to draw the line 99.5 plus 39.13. So when I add 99.5, I'll be getting 138.63. This is now the median, 138.63. That is the median. But now on the diagram, where is point 138.63? That is where we draw our vertical line, 138.63. So we have a 10 units. We have a 5 units representing 50. 5 small squares representing 50 units. What about one small square? It will represent 10. If it will represent 10, then it means that for us to have 139, we need almost 4 of them for us to add 39.13. Almost 4 of them. So at this point now, that is where I'm going to draw my vertical line. We use a different color. Remember, it is just an estimation. When we are using graph to determine some measures, we are just estimating. So the median line. The median line. You can even use the formula to calculate median and check whether you will get 138.63, and you will be discovering that it's just the same. From the same graph, we are also taught to use the histogram to determine the number of parcels with a mass of 300 or more. 300 or more. 300 or more. So we are supposed to check where 300 is. Yeah. 300 is going to be at this point, according to my estimation. 300 will be there. That is where 300 is. So the number now will be the area on this side, because we want or more. If it was about 300 or less, we would have gone to our left. But now that we need 300 or more, it will be 50 multiplied by the height of 1.7. 50 by 1.7. Yeah. 50 multiplied by 1.7. So 50 multiplied by 1.7 is going to be 85. Yeah, it's going to be 85. So we have 85 people. 85 people. So that is the statistics question that I thought it's good we work it out together. Number 18, question on equations of straight lines and gradients. A line L passes through -2, 3, -1, 6, and is perpendicular to a line P at the point 1, -6. Find part A, the equation of L. The first thing we're supposed to get is gradient M for line L. Gradient is given by change in y over change in x. So change in y means 6 minus 3 divided by -1 minus -2. That is where you're supposed to be very careful. -1, it's already a -1, then minus a -2. So this will be 3 out of -1 plus 2. And this is going to be 3 out of 1, which is 3. So the gradient is 3. If the gradient is 3, then now we can talk about expressing the gradient using the first coordinate, and another coordinate is let to be xy. So how do we get equation 3 equals to, how do we calculate gradient? The gradient of 3 equals to change in y over change in x. So y minus 3 out of x minus negative 2 minus negative 2, making it a positive. Remember, 3 is automatically over 1. So now we can cross multiply, whereby y multiplies by 1 multiplies y minus 3, and the 3 multiplies x plus 2. So y minus 3 equals to 3x plus 6. Yeah, 3x plus 6. At this point now we can remain with y equals to 3x plus 9. 3x plus 9. This is now the equation. Yeah, this is the equation of line L. Remember, line L is perpendicular to another line P at the coordinate -1, 6. Now part B, find the equation of P in the form. Now that they are perpendicular, we usually say for two perpendicular line, gradient 1 times gradient 2 should give us -1. Gradient 1 times gradient 2 should give us -1. Therefore, if gradient 1 is 3, then gradient for line P is going to be the reciprocal with opposite sign. The reciprocal with opposite sign. I can see you guys are seriously following. Remember to subscribe. Remember to share. Invite a friend kindly from your school or even beyond. Just invite people so that you may learn together. You can see that the video today is very stable. The network is good today and people are seriously getting knowledge. Now, look at this second gradient now. I made it a third, then with a negative, so that when I multiply a third by 3, I get -1. Now that the two lines are perpendicular at this point, we need to let another point be x, y, so that we now get the equation by just expressing this gradient. So we need to say -1/3, -1/3 equals to y minus 6 over change in x, x minus -1, x minus -1. Yeah, y minus 6, x minus -1, making it a positive. A cross multiplication will give us 3y minus 18 after multiplying by 3. The -1 here is going to give us a... Actually, we could have started with the side that has x, simply because when you look at the format we are advised to leave our equation, then it becomes wise for you to be guided by the format. And say we can even, yeah, you can be guided by the format or otherwise. It is not a must. Let me just work it out the way we had started, but it's good students to follow the format which we have been advised to leave the equations at 3y minus 18 equivalent to -x minus 1. You see at that point, now we have to take the constants to the right-hand side. And we have the variables on the left, whereby it is x to begin. If it is x to begin now, x becomes positive at this point, and it defines 3y at that point. This will be equivalent to, we take 18 to the right-hand side, and 18 becomes positive there. So -1 plus 18, it will become a positive 17. Yeah, a positive 17. Look at it keenly. A positive 17. Yeah, that way. A positive 17. So that is how we are supposed to work out the second part. I hope you guys are still remembering that you can access airtime from our facilities from all the networks working in Kenya, Safaricom, Telcom, Airtel, just go to your M-Pesa, Lipa na M-Pesa. The pay bill number 737356. Then the account number is the phone number that you're supposed to purchase the airtime for. The phone number that you're supposed to purchase the airtime for. Then after that, now you enter the amount, you complete your transaction, and you receive airtime instantly from our facilities. Remember to share this now with your friends. It's a pay bill that you can even memorize. Already you know your phone number, which is the account. Now the pay bill number is 737356. Yeah. Look at this. Look at this now, part C. Given that another line Q is parallel to L and passes through point 1, 2, find the X and Y intercepts of Q. So Q is parallel to L. We usually say if two lines are parallel, gradient of one is usually equivalent to the gradient of the other. If two lines are parallel to one another, the gradient of one is equivalent to the gradient of the other. So we need to know what was the gradient of L. What was the gradient of L? Gradient of L is 3. If gradient of L is 3, then the gradient of the new line Q is also 3. Now the line is passing through 1, 2. That means we can find the equation. Express gradient 3 equals to change in y minus 2, change in x minus 1. Yeah. Using that coordinate and another coordinate xy. Change in y minus 2, change in x minus 1. Across multiplication will give us a y minus 2 equivalent to 3x minus 3. So that at this point now we can talk of a y equivalent to 3x minus 3 plus 2 becomes negative 1. This is now the equation. You know, with the equation now it is easy for us to find the intercepts of this particular line. Intercepts at this point, let me illustrate what intercepts are so that people may know what we are working out, so that we are not just working out acrobats. This is a x, this is y axis. So when we talk about intercept, we mean, for example, I can see the intercept of this line is at negative 1. The other one will be somewhere there. So if we draw this line, there are the points where the line will cut the axis. Like that. So where the line cuts the y-axis is called the y-intercept. Where the line cuts the x-axis is called the x-intercept. So this is this point here is called x-intercept. That's called x-intercept. This point here is called the y-intercept. The y-intercept. Now, what you're supposed to learn about y-intercept and x-intercept is that the y-intercept is along the y-axis. So at the y-intercept, the values of x are usually 0. Anywhere along, if it is at negative 1, then the coordinate is 0, negative 1. If it is on the x-axis, that is the x-intercept, it is also going to be that along the x-axis, values of y are usually 0. If the values of y are usually 0, then it is good for us to know that the coordinate here will be x0. The coordinate here will be 0 and a value for y, like that. So with our equation, and there is the concept in Form 1 about linear graphs, whereby you're supposed to say that with a table of values of x and y, when x is a given value, we can get the value of x. So we are sure that at the point where the line cuts the x-axis, the value of y is 0. Then we insert 0 where there is y. So 3x equals to 1, and the value of x will become a third. So x-intercept is a third. This is the point where y becomes 0. What about when x becomes 0? The value of y will be -1. When x becomes 0, it means just substituting 0 at this point. And the value of y becomes -1. So y-intercept -1, x-intercept a third. X-intercept a third. Part D of that particular question, find the point of intersection of lines P and line Q. Line P and line Q. So we have the equation of Q, which is y equals to 3x minus 1. Y equals to 3x minus 1. The other line is line P. Line P. Find the equation of P in this format. So it is 0. X plus 3y equals to 17. X plus 3y equals to 17. Now, when you remember very well some Form 1 work, we talked about solution of simultaneous equations, whereby graphical method was one of them. And we said if two equations intersect at a point, then the coordinate of that particular point becomes the simultaneous solution of the two equations. If we plot a line and another one, and they are intersecting here, x, y, then x and y will become the solution of the lines which have been plotted. So in this case, we can also calculate the point of intersection. The point of intersection can be calculated without necessarily plotting. So we need to solve the two equations simultaneously. And how do we solve the two equations simultaneously? We can use the substitution method. Because we have already expressed y in one of the equations, we substitute it in equation 2. So equation 1 is giving us y, we have equation 2 here. So in equation 2 now we rewrite it x plus 3, and instead of y, 3x minus 1 equals to 17, right? Yeah. So we'll be talking about x plus 3x plus 3x, sorry, plus 9x after multiplying. Sorry for that. 9x. Then this is minus 3 equals to 17. You see now this is becoming 10x. And when we take 3 to the other side, we are getting 20. So we can talk of x becoming 2. If the value of x is 2, why don't we get the value of y? So y is going to be 3 into 2 minus 1. 6 minus 1, 5. So the point of intersection is given as a coordinate 2, 5. The point of intersection is given as a coordinate, which is coordinate 2, 5. Yeah, thank you for being around and following keenly and carefully. I said you guys can comment, can subscribe, can share. Thank you. I can see people are really following up. Wow, thank you. Thank you. Yeah, let people continue watching us. Number 19 now, which is our third question. The concept is on a measurement whereby we deal with volumes and surface areas. Yeah, volumes and surface areas. Find surface area of this frustum and also volume of the frustum shown. So the first thing that we're supposed to do here is to find some unknown distances. Remember, we have a frustum whereby we usually say that there is the original cone from which the frustum was obtained. There's an original cone from which the frustum was obtained. So if this is our original cone, if this was our original cone, then we are having the height of the frustum. We can also get height of the original cone. Height of original cone. Remember, there is the small cone which was cut off, and according to similarities and enlargements, we can just find the missing height, whereby we say when we take, remember, both radius and height are one-dimensional measurements, which means they give us linear scale factor, both of them. So the ratio of the radii 3.5 and 2.8 should also be the same as the ratio of the heights. When we pick a vertical height of 5 plus small h, which was cut, and we divide by the small h, we will just get the same. So original height 5 plus h divide by height of the smaller cone which was cut off, we get the same ratio. So across multiplication will give us 3.5h equals to 2.8 by 5, giving us 14 plus 2.8h. So 3.5 minus 2.8, I'm getting a 0.7h equals to 14, and the value of h can be calculated. So 14 divided by 0.7, giving us exactly 20 centimeters. So now we are having the height of the cone which was cut off. This is an indication that we can get height of original cone. Height of original cone shall be 20 plus 5, giving us 25 centimeters. Yeah, 20 plus 5, giving us 25 centimeters. Now that we have the vertical heights of this particular cone, we can get what we call slanting heights. We can get what we call slanting heights. Slanting height shall be, we are supposed to apply now, slanting height is capital L here. We get Pythagoras theorem, because for this cone we know vertical height is 25 and radius is 3.5. Then we can get the height there, slanting height, which will be given by, when we take 3.5 and we square, then we add 25 also squared, and we obtain the square root. We shall get it right. 3.5 squared plus 25 squared, then square root. You know, I'm getting 25.24. 25.24 centimeters. 25.24 centimeters. There is also a small slanting height. A small slanting height for the cone which was cut off. For the cone which was cut off. Small l. Pythagoras theorem again. We need 2.8 squared plus the height there which was cut off is 20 squared. Then we obtain the square root. That is Pythagoras theorem. We will be able to get the slanting height. 2.8 squared plus 20 squared. Then we take square root. I'm getting 20.20. 20.20 centimeters. 20.20 centimeters. Now we have to calculate the surface area. Yeah, we are to find surface area. I'm assuming that it is a solid frustum, so that we talk about curved surface. Curved surface area of a cone is given by pi RL. So for this case, we need pi RL. Then we subtract the cone which was cut off, pi RL. So I'm using capital letters minus small letters. So curved surface area will be 22/7 by a radius of 3.5 and a slanting edge of 25.24. Minus 22/7 multiplied by a radius of 2.8 multiplied by 20.20. 20.20. So now we can compute this. 22/7 multiplied by 3.5 multiplied by 25.24. This gives us 277. 277.64. Then we subtract 22/7 multiplied by 2.8 multiplied by 20.20. This is going to be 177.76 square centimeters also. So 277.64 minus what we are getting now is 99.88 square centimeters. But now we're supposed to know that this is now the curved part. If this is the curved part, then we can also work for the top radius and bottom radius. So top, which is a radius, which is a circle, top circle, the area of a circle is pi r squared. So we need pi r squared. Then the bottom circle, pi r squared, pi r squared. So 22/7 multiplied by 2.8 by 2.8. This will be 24.64 square centimeters. Then 22/7 by 3.5 by 3.5. Then this is going to be 38.5 square centimeters. Now, for us to talk about total surface area, we need to add, total surface area. We need to add all the surfaces now. We need to add all the surfaces, whereby the curved surface, 99.88, the top circle, 24.64, the bottom circle, 38.50. This is going to be equivalent to 99.88 plus 2.464 plus 38.5. So I'm getting 163.02 square centimeters. 0.02 square centimeters. So that is the total surface area of the frustum shown up there. Let's also remember that there is a part B whereby we are told to find the volume of the frustum. Find the volume of the frustum. Yeah. Thank you. I can see your comments. I can see your positive reactions in this particular lesson. So thank you so much for being around. We treasure you so much. Remember that you guys can get airtime of any amount for any network by just going to M-Pesa, Lipa na M-Pesa. The pay bill number is 737356. Then the account number is your own phone number. whether Safaricom, Airtel, Telcom, you just say that the account number is that phone number. Then the amount, you enter the amount you'd like to spend. Then now you proceed to complete the transaction and you get airtime instantly. Yeah, you get airtime instantly. So remember to utilize this facility and also to invite your friends to the same 73, 73, 56. Look at the part B now, whereby we say that a volume of a cone is given by a third pi r squared h. Now, this one being a frustum cut from a cone, we need a third, we need a third pi r squared h. Then we subtract a third pi r squared small h, so that we get volume of original cone minus volume of the smaller cone which was cut off. Yeah. So now we have to substitute now. A third pi r squared, then the first capital H, 25. Now we will be subtracting a third pi r squared, the small h of 20. Yeah, the small h of 20. So let me compute now each. A third multiplied by 22/7 multiplied by 3.5 multiplied by 3.5 multiplied by 25. This is a volume of 320 for the original cone, 0.83, minus the cone which was cut off. A third multiplied by 22/7 multiplied by 2.8 multiplied by 2.8, then times the vertical height of 20. I'm getting 164.27. So now we can work out the exact volume of this frustum which remained after a cone was cut off. 0.83 minus, yeah. So I'm getting exactly 156.56. And this is cubic centimeters now. Yeah, cubic centimeters. So that's how we get the volume of a frustum, which has been obtained from a cone, which has been obtained from a cone. Look at number 20. The figure below, which is not drawn to scale, shows a triangle ABC inscribed in a circle, just as you can see, inscribed in a circle. Then we are given some dimensions. AB 6 centimeters, BC 9 centimeters, and AC 10 centimeters. Calculate to 2 decimal places. Very serious instructions. Calculate to 2 decimal places the size of angle ABC. B being at the center, we need the angle at this point. Then something else you're supposed to know is that in trigonometry 2, you know this solution of triangles, a subtopic in trigonometry 2. Usually say that if this is a letter B, we use it to name the angle, but the opposite length will bear small letter b. So with C at this point, the angle is called C, but the side which is opposite, small letter c. With A here, the side which is opposite will be small letter A. Small letter A. So that is how we work in such a topic. Now, we are supposed to apply the cosine rule, which says that, you know, what we want is B. So when we take the length B squared, we will get A squared plus B squared minus C squared minus 2AC multiplied by the cosine of the angle at B. Yeah, the cosine of the angle at B. Therefore, I begin by saying that B, which is a known, no, the length B is known. All sides are known, sorry. All sides are known. B is 10 squared equals to A, which is 9 squared, plus C, which is 6 squared, minus 2A C cosine of the unknown angle at B. Cosine of the unknown angle at B. So let me first take 100 minus 9 squared, which is 81, and 6 squared, which is 36. I'm getting negative 17 equals to negative 2 by 9 by 6, negative 108 cosine of B. So that for me to remain with cosine of B, I'm supposed to divide by negative 108, negative 17. So when I divide the two, the negative cancels, and this becomes 0.1574. This means for me to get the value of B, I need to obtain the cos inverse of 0.1574. So the value of the angle at B is going to be shift cosine this value. So I'm getting 80.94 degrees. Remember, we've been told to 2 decimal places, so you're supposed to be extra careful to follow such instructions. 80.94. 80.94. Good. Part B now. We're also finding the radius of the circle. We know that a radius, twice the radius, is equal to what we call the sine rule. You know, sine rule says when we take A, divide by the sine of A, we get the same as B, divided by the sine of the angle at B, C, divided by the sine of the angle at C. And this is usually the same as twice the radius of the circle. Twice the radius of the circle. So now allow me work with the side and opposite angle, which are complete. For example, for B, I'm having both B as 10 and the angle as 80.94. So when I take 10, a length of 10, divide by the sine of 80.94, I will get 2R. Yeah. So 2R is equivalent to 10 over the sine of this angle. I'm getting 10.13. For me to remain with R, I have to divide it through by 2 now. For me to get 5.06 centimeters. So this is now the radius. Yeah, this is the radius now that we wanted. It's called solution of triangles. Solution of triangles. Look at part C. The examiner is demanding the area of the shaded region. Which is the shaded region? The area which is inside the circle but outside the triangle, the shaded area. So we need the total area of the circle minus area of the triangle. Circle minus triangle. Circle minus triangle. Therefore, area of a circle, shaded area, in other words, the shaded region, we need circle by r squared minus area of the triangle, which will be half AB, the sine of theta. I know there are many ways of getting area of a triangle, but allow me prefer half AB sine theta. So when I talk of 22/7 multiplied by radius squared, I'm having 5.06 squared, then minus half multiplied by one side, which is 9, multiplied by one side 9, another side 6, 9, 6, sine of the angle between them, so sine of 80.94. So for the circle, I'll be having 22/7 multiplied by 5.06 squared, and this will be 80.49. 80.47 minus half multiplied by 9 multiplied by 6, the sine of 80.94. This will be 26.66. This is going to be, when we subtract 80.47, sorry, minus 26.66. So I'm getting exactly 53.81 square centimeters. 53.81 square centimeters. Yeah, 53.81 square centimeters. So that is it. Yeah, remember to invite friends to this particular broadcast. I officially invite all your classmates, and I'm going to use you. Remember to share the link for this particular lesson. Look at number 21. The figure below shows two intersecting circles with centers A and C. Then the radius are 5 and 8 respectively. Just as you can see on the diagram. The common chord EF is having a length equivalent to 6 centimeters. EF 6 centimeters, which means we will have 3 centimeters, 3 centimeters. Calculate the angle EAF. EAF means the whole of this angle. Now, following triangle EAF, we can apply trigonometry, whereby I will use a, I need the angle at this point first. Let me draw it. I'm redrawing triangle EAF. So this is right angled. This is 3, and this is 5. So what about the angle at this point? So the angle at that point, we apply a ratio that we call sine, and say that the sine of alpha equals to opposite over hypotenuse. So how shall we get alpha? We get alpha by taking the sine inverse of 3/5. This gives us what? Shift sine 3/5. This gives me 36.87 degrees. What about the angle now? EAF. It will require twice alpha. 2 multiplied by 36.87. This will be 73.74. Yeah. So the whole angle at this point now, we have to multiply by 2. So that is how we work it out. Let's check the other angle, ECF. ECF, I also extract ECF in such a manner. So for ECF, we're going to do the same thing, whereby this is 8 and this is 3. Therefore, the angle theta at this point, we say that sine theta equals to 3/8. Which implies that for us to get theta, we need a sine inverse of 3/8. This is going to be, take shift sign, 3/8. This is giving us exactly 20.02 degrees. Now, can we talk about angle ECF, whereby we need to multiply theta by 2. So it's 2 multiplied by 20.02, and this will give us 40. Sorry, just a minute. Shift sign 3/8. That gave me 22.04. So not 20, but 22.04. So this is 22.04. So when I multiply by 2, I'm getting a 44.05. Yeah, degrees. 44.05 degrees. Calculate the common area between the two intersecting circles. Calculate the common area between the two intersecting circles. So the common area, we can see it's a joint chords, whereby for me, if I say for example, this is area 1 and this is area 2, the first area is a segment. We call it a segment. Segment is area bound by a sector and a triangle. So for me to get the area 1, I need the sector ECF and I subtract the triangle ECF. Yeah, the sector and I subtract the triangle because it is a minor segment. Therefore, sector 1, the segment 1 here, the small segment, you need the area whereby I need theta over 360, so 44.0 over 360 pi r squared minus half 8 by 8 sine 44.05. So from the sector 44.05 divided by 360, I multiply by 22/7 multiplied by 8 squared, which is 64. I'll be having 24.61. Then I subtract half 64, the sine of 44.05. So I'm having 22.25. So 22.61 minus 22.25. This is 0.36. Yeah, I'm supposed to check 24.61. I subtract 22.25. This is 2.36. Sorry, 2.36 square centimeters. This is now area of the first segment. What about the second segment here? Area 2. The second segment, area 2. I'm working on the space here. For me to get area 2, I need sector EAF, and I subtract triangle EAF. Therefore, for the sector, theta over 360, what is theta? The angle at the center, 73.74. Over 360 pi r. The r in this case is 5 squared by 5. Then we subtract the triangle. I have AB, sine of the angle at the center, so sine 73.74 that way. So let me work out the sector first. 73.74 over 360 multiplied by 22 over 7 multiplied by r squared. So I'm getting 16.09 square centimeters minus half AB multiplied by the sine of 73.74. I'm getting 12. So 16.09 minus 12. This will give us 4.09 square centimeters. Then the total shaded now will be this area plus the other area, which is 2.36. Let's confirm that. 2.36, yeah. This is going to be, when I take 2.36 and I add what I'm having here, I will end up with 6.45 square centimeters. So that is the shaded area. Ensure you subscribe to this platform. Ensure you also get airtime of any amount for any network by going to your M-Pesa menu, Lipa na M-Pesa, the pay bill number being 737356. Then the account number is your own phone number. It can even be the number of a friend if you want to purchase airtime for a certain friend. You go to the M-Pesa, pay bill number 737356. Then the account number is that particular phone number, which could even be of a friend. You buy airtime for it, then the airtime is going to reflect instantly. We are ending there. Have a good night. See you tomorrow. Thank you.